fly like you stole it.
Right, note to self, when you do a video, press record. That's a whole 20-minute spill I just did there, and now I've got to do it again. But never mind, it was a good practice. So, what we're doing, I'm going to build my first long-range quad, but I'm going to build it in such a way with a build guide, a configuration guide, that anybody can follow it from start to flying quad, learn something, or just get a little bit of extra knowledge they need to push them into building their own long-range quad. It's quite new in the hobby at the moment. Lots and more people are doing it. So to help other people, Unmanned Tech have sponsored me this build. All the parts are from them, and will be all the guides I'll be hosting on the Drone Trust forums as a build log, a build guide as well, and plus these videos. The videos will cover anything useful, start to finish, including the first flight, be it a good flight, bad flight, instant crash. It's all a learning experience to me and to other people, so hopefully you can all gain something out of my experience in doing this. So starting from the frame then, I'm using a GEPRC Mk2 frame. I'll post an image on the screen somewhere, but I'm using the 7-inch frame, not the 6-inch frame. Now, I've got 7-inch frame, but 6-inch props. Now, the reason I did that is because you go 6-inch arms, you can only do 6-inch props. 7-inch arms, you can do 6-inch arms, 6-inch props, or 7-inch props. So if you want to change up later on, you can do that. And plus the extra spacing between the front props and the back props, I'm told when you're pitched forwards, your front props create turbulence. Obviously, as it pushes you behind, they get mixed into the back props, which they then have to fight through, and your flight controllers have to work for. So 7-inch arms, 6-inch props, hopefully give a bit more clearance and clean up that air a little bit. Now, moving inwards, so I've got the frame, motors. I've gone for the Lite Spec 2207 1900 kV motors from Emax. Great fan of Emax motors. I use them on all my builds. And I have here the 6-inch AVAN long-range props. These are 6 by 3.8 props. Now, according to Emax, these props are paired to these motors. So that's where I'm starting. I could copy someone else's, but I'm a fan of Emax, so I'm going to give these a go, and Emax say they should work together quite well, so I shall give it a go. Moving inwards on the frame then, ESCs, I've gone with the RAF 32 V2 ESCs. These are 30 amps a piece, and these things are tiny. I thought the arms were skinny on this frame, but these will actually, you're not going to be able to see that, I don't think, just hang over. Now, when I got these, they said they were naked, and they really are. There's no wires of these at all, so something else you have to consider is going out and buying silicone wire with all different gauges to pick up from the ESC pads to the FC, the telemetry wires, signal wires. That's one of the reasons I went for these. These have a telemetry line on them as well. So each ESC has a, where is it, just there, current sensor. So the OSDs should report on these as current draw per motor, and only motor that is. Also RPM, temperature, and I'm interested to see what else these can these do. And they're not actually that heavy. Now all that's going to be connected into a flight controller. Now the flight controller is not here yet. Unmanned Tech haven't quite got it in stock. That is on its way. It is the Airbot Fireworks V2. It's a unique board, cutouts for the motors. Now I like that because it supports, it's an all-in-one, so it's one board, it's lighter. You don't need a higher stack, which will come in useful in a little while. But also on each of its motor pads is an ESC tab as well. Not an ESC tab, sorry, a telemetry pin. So again, I picked the ESCs with telemetry, and I picked a flight controller that was capable of taking those telemetry, and they were easy to wire up because they're all nicely placed. I'll probably do a different video on the flight controller, covering it briefly as I fit it into the frame. covering a few bits and pieces as I find out. Now for video, I have a Unify Pro V3. This is the 5-volt version. Of course, there's a little bit of an issue with the build, but I'll cover that in a minute. That is going to be paired with the Lumenier AXII Stubby. This little thing here. This causes another build problem, but I shall cover that as well. For FPV, I got a RunCam mini split. I wanted something that could do flight and HD recording because I don't want to mount a HD camera. My RunCam 3 has recently died. I've wrapped it around a tree, and I'm not paying for a GoPro 5 session, well, even if you could get them now anyway. And for the receiver, Crossfire. This is the micro receiver. This thing, look at this, is tiny. So I'm looking forward to getting that on this long range build. I've already bought one before and installed it onto my Tranis and my freestyle quad to get the feel what it's like, get it set up. Using it, I found that plugging the transmitter module in the back of my transmitter, the pins in the transmitter at the back, you've got to be really careful how they feed in because they can slip and miss. Took me a couple of attempts to actually get it in. I was a little bit concerned at one point because the module wasn't powering up, and it turned out that when I took the module out again, it was really stiff getting it out. I could see marks on the module where the pins had missed. So they took a little bit of a bending in and then slotting it back in again. Now, this is my first time flying Crossfire, and I'm learning as I go. I found things like the stable release firmware kept giving me telemetry warnings, and you could watch the link quality drop quite dramatically and come back up again. I got mini fail-safes where you'd be doing a maneuver and then the quad would hold and then recover again. And I worked out as well that Crossfire gives you an amazing range. I haven't actually gone out further than 500 meters. I keep running out of distance and bottle, but then sometimes when I'm flying down a hill, I'm forgetting the fact that where I am to where the quad is on a hill, and all that ground the Crossfire's got to penetrate through, and it just doesn't do it. So when you fly Crossfire, what I'm finding is same level or higher and you're all good. You drop below too much ground and Crossfire's just not going to get through it. I don't think anything will. There's a lot of ground to penetrate through. So back to some of the building problems I found before I even put this thing together. Now, Stubby doesn't have a coax at all. No length, no line. So it has to be attached directly to the SMA of the Unify. Now this thing flexes, so you can't have that hanging out the back of the quad. It's just not good. So I have a method where I have 3D printed a TPU mount, not designed. The back standoffs will go through the holes. SMA will fit on the top and then come through, and then you just screw the stubby on top, and this is all TPU, so it's flexible, so it should take a knock. So that was the first thing I had to solve. Second was a bit of a power, because the Airbot has two BECs on it. It has an 8-volt 1 amp and a 5-volt 1 amp. Now the 8-volt 1 amp is fine for the RunCam because it takes 5 to 15 volts, and that'll run about 600 milliamps, so that will max out most of that BEC. But then you've got the 5-volt Unify. This thing is 600 milliamps on its own. The Crossfire, that's also 5 volts. When it arrives, the GPS module that I'm using, a little mini GPS, that's also 5 volts. So I was a bit wary of pulling too much through that 5-volt BEC. So I had a look at different spec sheets, found out how much Unify pulls, how much the Crossfire pulls, how much the GPS pulls, and I'm going to be pulling close to 800 milliamps through that 1 amp BEC, so it should be okay. It'll be something I have to be wary of and keep an eye on during builds in case I run into any problems. Now I think I've gone through all the parts, but I have missed one. I have full cell 1800 milliamp Lipos from TATTU. So if I butcher any names during this, I'm terrible at pronouncing names properly and I'll butcher something. Now, why did I go full cell, not 6? ESCs will take 6, flight control will take 6, motors will take 6. Now, I wanted to keep everything the same. I use full cell on my freestyle quads, and I wanted to keep full cell as a start point at least on the long range quad, so I can charge all my Lipos together, so then I don't have to do a bank of 4S and a bank of 6S. I can just put them together. My freestyle ones are 13 milliamps, 1300 milliamps, these 1800 milliamps, so I could put them all together on the same balance board and charge them away quite happily while keeping an eye on them. So that's why I went for this. These are actually smaller than I thought. If I open this one up, yeah. And they're actually longer, but they're smaller than I thought. They're less square, so that will work quite well because that will sit on the top deck of the flight of the frame, which is where I'm going to mount this. Quite further back, I have room to get the CG right by placing it too far forwards or back. The XC60, let's cut this off, is quite short as well. So if I side mount my battery, the flight controller, I might have to put a bit of a pigtail on it to make sure that's not overstretched. Or I could mount the flight controller so the XC60 is at the back. Pick out things you got to consider when you build frames, not just long range frames, but anything really. Take some time to look at your parts, think about what you do, what you want to do, what you want to accomplish, and come up with that plan. So I printed this last week before I even had the frame. I'd already thought about how I wanted to mount it, gave it some thought, found some dimensions online, and then modelled the standoffs gap for that. Plus it's TPU, so it should flex quite well. So that was that. So I think that's it for this video. I think I covered most of the parts. I'll start building it really soon now. I can do the frame, motors, I can think about placing the ESCs on and how I'm going to protect them from the carbon arms. Because again, these don't have any heat shrink over them. I have got some on order, it should be here any day. I'm not sure I'm going to go for double-sided sticky tape and heat shrink, or put the heat shrink over the whole arm, or even design. You can't really say it's written in pencil. I took some measurements of the arms and the ESCs now, got them in my hand, and I'm looking at maybe doing a TPU shield to go over the top. TPU rather than PLA. TPU, as you've seen, is flexible. It would take an impact, I think, better than PLA. I think PLA just crack and smack, crack and break. So I might give a go of 3D printing them, and then mounting the TPU shield over the top. Bit of electrical tape round. I prefer electrical tape rather than zip ties. I find that zip ties, you can't never get them tight enough, and if they slip, you might damage one of the capacitors or one of the parts on the ESC, and they snap. Electrical tape was never snapped on me yet, and it's they may unpeel a little bit, but you can just unwrap it and wrap a new one on it. It's nice and easy, quick fix. Keep some in my flight bag. But I think that's mostly it. So this is the first video. There'll be other videos to go. I won't do a video on how to build a frame. It comes with instructions. I'm sure it's not that difficult to do. If we can build quadcopters of any size, then I'm sure we can follow instructions, and I shall put the frame together, mount the motors on it, put the ESCs on it, and I'll probably do a video at that point, sharing my experience and what I've learned up to them, start to wind up the FC, and hopefully do a half decent job on my soldering, because that's going to be on video. So for any questions, you can ask them below. or you can go across to Drone Trust forums, where there'll be a build log as I take pictures and put little bits of information down that will probably end up in the build guide itself or in the video as they get released and finished up. All the links to all the parts will be below, as well as the links to the Drone Trust forum where the build log will be, and eventually the build guide as it's completed. That should have enough information to take you from parts to your first flight. I'm going to try and cover everything from a betaflight configuration, first plug ups, things to do before your first flight, things to consider before your first flight. Just simple things like checking all your screws on the bottom. I've flown before, crashed, and found that one of my standoff screws in the FC was missing. I had to replace it before I went flying the game, because you don't want your FC bouncing around too much. It will just upset your gyro. Right. Yeah, that's it for now, guys. Thank you for watching, and I will see you in the next video.